Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers box plots. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 19, here is a box plot and we're asked to circle the value of the range. Now the range is given by the lengths of the whiskers, so from one end to the other. So the whiskers start at 80 and go down to 30, so the range then is going to be 80 subtract 30, which is going to be 50 units, so my answer is that one there. Circle the median. Well, the median value is this line in the middle. Now according to my scale, that is 60, well there are 5 squares between 60 and 70, so each one must be 2. So that means that the median must be 64. Circle the value of the interquartile range. The interquartile range is given by the distance from the interquartile range is given from the distance from the lower quartile up to the upper quartile. So this distance here. So the lower quartile is at 38 and the upper quartile is at 74. So the interquartile range is going to be 74 minus, what did I say it was? 38. 74 subtract 38 is 36, isn't it? That one there. Question 16. Here is a box plot. Circle the median value. Well, I'm sure you all know what's what on a box plot. This is the lowest. This is the highest value. This is Q1, our lower quartile, and Q3, our upper quartile at the edges of the box, and the line in the middle is Q2, or the median. So our median value then is going to be this number here. There are 5 divisions between 20 and 30, so each division must be worth 2. So counting up from 20, 22, 24, 26, 28. So that is going to be a median value of 28. Question 19. In the UK in 2000, 25% of the population were under 24 years old, 50% of the population were 37 years old, and the interquartile range for the age was 32 years. The oldest person was 107 years old. Show this information on a box plot. Now, a box plot has a box in the middle and 2 whiskers and a line in the box like that. That line in the box is Q2, the median, and then we have Q1 and Q3, the upper and lower quartiles, and the whiskers go out to the highest and lowest values. So in order to draw this box plot, we need to know those 5 values there. So let's go through the question and see what it's telling us. 25% of the population are under 24 years old. Now 25% of the way through a population is going to be the lower quartile. So this is actually giving us Q1. So Q1 is 24. 50% of the population were under 37 years old. So halfway through the population is our median. So actually they're giving us Q2 there. That's 37. Now the interquartile range was 32. Now the interquartile range is the distance between the upper and the lower quartile. So we can use our lower quartile 24 and the interquartile range to work out where the upper quartile is 24 plus 32 gives us 56. So Q3 is at 56. Now the oldest person was 107 years old, so that's given us the maximum value is 107. And what's the minimum value? Because we need to have the lower whisker, don't we? Well, we're going to assume that the lowest person's age is just fractionally above 0. So we'll put that one in there. It doesn't give us any other information, so that's a natural assumption. Okay, so we've got all the data we need. We can now draw it on. So getting the ruler out, I'm going to draw a line at 24, 37 and 56. 24 is going to be my lower quartile. 37 is my median. And 56 is the upper quartile. You see there are 5 divisions between each 10, so they're worth 2 each. Okay, so just turning my ruler around, joining that up to make a box. And then I can add the whiskers on. So the whiskers go to my min value, so down to 0, and to my maximum value, so up to 107. Okay. So there we go. Job done. Part B says it is predicted that in 2050 the age distribution in the UK will have a lower quartile of 26, a median of 44 and an upper quartile of 66. Make 2 comments about the predicted change in the age distribution in the UK. So I think I want to do 2 comparisons between the 2 different types of data we've got here. A median is a measure of average, so I'm going to compare the medians. And interquartile range is a measure of dispersion, so I'm going to compare that as well. So what is the interquartile range? Interquartile range is going to be Q3, our upper quartile, minus Q1, our lower quartile, which is 40. Okay, so I'm going to be comparing the medians and the interquartile range. So let's look at the medians first. So my new median is 44, and from the first part of the question, my median was 37. So the median has gone up. So in terms of the age of the population, it means that people on average are going to be living longer. So median age has increased from 37 to 44. So people are older on average. And secondly, the interquartile range has increased also. So the interquartile range has increased from 32 to 40, meaning that, well, it means that there's more variation in the ages of people, meaning that there is greater variation in people's ages. Okay. Question 17. Some girls and boys take an exam. Here is some information about the marks for the girls. So we know the lowest is 16, the highest is 78, the lower quartile is 24, the upper quartile is 66, and the median is 48. We need to draw a box plot for that information. Okay, well, that's all very easy. We're going to have a box in the middle. This would be Q1, the lower quartile. This would be Q3, the upper quartile. and Q2 is the median in the middle, and we're going to have whiskers going out to our lowest and our highest value. Okay, that's what it's going to look like. So now we can draw that neatly on the graph. So I'm going to get a ruler and place it on each of these measurements so I get it absolutely accurate. So the first one, the lower quartile, is at 24. So let's mark that on the scale. Okay, and then my upper quartile is at 66, which is there. And my median is at 48. Should be there. Okay, so let's just turn the ruler around, complete our box. Oops. Okay, so there's my box part, and now the whiskers are going to go out to the highest and lowest values. So the lower whisker is going to go down to 16. So 16 is here. And then the the highest value goes up to 78. Should have done it that way around so I can see the scale at the same time. And the upper whisker goes up to 78 there. Okay, so that's my diagram complete. So B, here is some information about the marks for the boys. We know the median is 45 and the interquartile range is 39. Whose marks were more consistent? Now consistency has got to do with the dispersion, and the measure for dispersion is the interquartile range. So if I want to compare their consistency, I need to know the interquartile range for the girls. So for the girls, the interquartile range is going to be the Q3 subtract the Q1, which is 24 and 36. That's 66, isn't it? So 66 minus 24, which gives us an interquartile range of 42. Now compare that to the boys, which has an interquartile range of 39. Because the boys' interquartile range is smaller, it means there's less variation in their scores, and therefore they must be more consistent. So I'm going to say the boys are more consistent. And the reason is that the boys have the lower interquartile range. Okay. Question 13. Here is some information about the length of time cars stay in a car park. So the shortest time is 30 minutes, the longest time is 12 hours, the lower quartile is 2 hours, the interquartile range is 3 hours, the median time is 4 hours, and we need to draw a box plot to show this information. Now a box plot consists of a box with a line in it and two whiskers that spread out like that. This value down here is going to be the lowest value, so that is going to be my 30 minutes. The one at this end is going to be the longest time, so that's going to be my 12 hours. The lower quartile is this one here, that's Q1, so that's going to be 2. The interquartile range is 3. That means that the distance between Q1 and Q3 is going to be 3, and 3 more than 2 is 5, so that one's got to be 5 up there. And we're told that the median is 4. That's my value of Q2 goes in the middle. Okay, so now I know where all my values are. It's always a good idea to do a little sketch like this. Just sketch it out before you commit pencil to paper, and then you'll get a neat go first time. Okay, so we're going to mark all those values on. So time to get the ruler out. Right, so I'm going to draw a line at 30 minutes, which is half an hour. So that's going to be halfway between 0 and 1. Now you should be drawing this in pencil. I'm going to use blue ink because my pencil won't show up very well. But all diagrams should be done in pencil. Then I'm going to draw a line at 2. That's going to be my lower quartile. I've got to draw a line at 4. That's going to be my median. I draw a line at 5. It's my upper quartile. And I'm going to draw a line at 12. Showing this off the line, oh no, that's no good. And one at 12 then. That's going to be my highest value. Okay, and spinning the rule around. I'm going to make my box here. And then I'm going to draw my whiskers, reaching up and down to my highest and lowest values. So a line there, and a line there. Okay, perfect. In a survey, queuing times at supermarket checkouts were recorded. One morning, samples of 50 customers were taken at supermarkets A, B, C and D. And the box plots representing the results are shown here. So these are a measurement of queuing times then. Okay, and we've got the 4 different shops, A, B, C and D, and each of the shop has its own box plot showing the quartiles and the highest and lowest values and the median. Okay, so the question says, on average, which supermarket had the lowest queuing times? Give a reason for your answer. Okay, so average here would be the median. Now the median is the middle line in your box plot. So we're talking about this one here and this one here and this one here and this one here. Okay, and the lowest queuing time average is going to be the one which is lowest down on the scale then. So that is going to be C, isn't it? Because C is at 4 minutes. Where D, which is the next one, is at 5, and then B is at 6, and A is well up there, it's long at 10. Okay, so the supermarket that has the lowest queuing time is going to be C. I'm going to say it's supermarket C, and my reason is the median wait time, which was 4 minutes, is the lowest of the 4 supermarkets. Okay, we're not done. There are more questions to answer. So part B says, at which supermarket were the queuing times the most consistent? Okay, so consistency is, they're talking here about dispersion, how widely spread out your values are. Now, box plots actually have 2 different measures of dispersion included. You've got the distance between, or how wide the box is itself, that's your interquartile range, and you've got your whiskers that spread out to the highest and lowest values. So if you subtracted one from the other of those, it would give you the range. So box plots give you the range and the interquartile range. Now, if you're given both, then I would suggest that the interquartile range is going to give you a better estimate because it's less affected by outliers. Okay, so given both of them, I'm going to be looking at just one. I'm going to look at the interquartile range on the basis that that is a better measure of dispersion than range. Okay, so what is the interquartile range of our 4 values? So our interquartile range then for these, okay, so let's have a look at A. Now the lowest value, Q1, is this one here, look, and that's at 8 minutes. And it's Q3, its upper quartile is in there. That gives us an interquartile range of 7. Sorry, it's 12 take away 7, isn't it? It's got an interquartile range of 4 squares. Okay, now my next one, B, the interquartile range goes from Q1 there 5 up to Q2, which is 7, Q3, sorry, which is 7. So that gives us an interquartile range of 2. Supermarket C, it's got quite a wide variation here. Goes from 3 all the way up to 8, giving it an interquartile range of 5. And then D goes from 4 up to 7, giving us an interquartile range of 7. So in terms of the interquartile range then, the one with the least amount of variation then is going to be this one here, which is B. So B has the least variation, so it's the most consistent, isn't it? So which supermarket has, were the queuing times the most consistent? It was at supermarket B, and my reason was the interquartile range was smallest, and it was 2, wasn't it? Okay. Now, like I say, you could have used the range here, and I suspect that you'll be given full marks if you did, compared the range of the 4 of them, but interquartile range is a better measure of dispersion, which is why I chose it over range. Question 19. Type A batteries and type B batteries were tested. The cumulative frequency diagram shows the information about the battery life of type A. And we can see it's got one of those distinctive S-shaped cumulative frequency curves. Estimate the interquartile range for type A. Okay. Now you can see that we've got altogether, we've got 80 batteries in this sample. Okay. Now the interquartile range is the middle half of your data. So basically you need to look at the range between 1/4 and 3/4 of the way through your data set. So 1/4 of 80 divided by 4 is 20. So we're going to read across from 20 to the graph. So from 20, I'm going to read across to the curve and then switch down, and that will be our Q1 value. It's not drawn along the ruler particularly well today. What's going on? Okay, now it's done it. So, and then 3/4 of the way through the data is going to be reading across at 20 times 3, 3/4. It's going to be at 60. It's going to be easier. Okay, and then when we hit the curve, we're going to switch and draw down. So my Q1 is there. Look, that's Q1. Lower quartile. My upper quartile is here. That's Q3, which is 3/4 of the way through. Q2 is the median. So Q1 is lower quartile, Q3 is the upper quartile, and then the interquartile range then is the distance between those. Interquartile range, which is Q3 minus Q1. So from my graph I can see that Q3 is 1400 and Q1 is 1100, and 1400 minus 1100 is 300. Question 19b. Estimate the number of type A batteries that had a battery life of more than 1600 hours. Okay, let's go back and look at the graph. More than 1600 hours. Well, 1600 hours on my graph is here, look. So we're going to use our community frequency curve the other way around this time. So rather than reading across from the frequency and down, we're going to read up from 1600 until we hit the curve, and then we're going to change direction and read across. Okay, struggling to draw on this line today. Go on, stop being annoying. Okay, done it. Right, so what's that value there then? That reads to me like 76. So up there is 76. Now what does that tell me though? That tells me that 76 batteries had a battery life of 1600 hours or fewer. Okay, now the question didn't ask me that. It asked me how many batteries had a life bigger than 1600. So it's not the 76 as my answer, it's my difference between 76 and the top, which is 80. So the difference between 76 and 80, those batteries had a life longer than 1600 hours. So it's going to be 80 subtract 76, which is 4. So it's going to be 80 subtract 76, which is equal to 4 batteries. Okay, now part C says the box plot shows information about battery life of type B. On average, which type had the greater battery life? Tick the box. Well, the greatest battery life is going to be given by the median here, I suppose. So it's like the average life expectancy. So here the median is the Q2 value. It's the one in the middle of your box plot, and if you read down you can see that it's 1300. So type B has a median value of 1300. So let's compare that with the median value for type A then. Going back to the graph. Now we didn't work out the median, we worked out the lower and the upper quartiles. Now we can find the median by looking across from halfway through the values. So again, reading across from 40. Ruler, what's up with you? Okay, let's draw in again now. And then switching around and drawing down. Okay, I can see my Q2 value or median is there. So I read that to be what, 3 out of 5 little squares up from 1200. So if there are 5 little squares between 1200 and 1300, which is a span of 100, then each little box is worth 20, then, isn't it? 20, 40, 60, 80, 100. So 3 little boxes is going to be 60. So I read that off as 1260 as the median value from type A. So we said that type B has a median of 1300 and type A has a median of 1260. So B is the biggest medium, isn't it? So what do we have to tick? On average, which type has the greater battery life? B does. State how I chose my answer. Well, I've shown that. That's all fine. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.